So that's me. Yeah, so I'm here to talk about a project for an applied LLM at Datavant called Project Stork. Basically, we taught an LLM how to be an expert at a very specific task that we then ask it to repeat tens of thousands of times a day, and we've had a lot of success with it. Real quick, first, I want to do a small recap of Datavant. If you didn't hear my colleague Rob Bowers speak earlier, I just stole one of his slides here. Very basically, we are trying to move a bunch of healthcare data around to drive better healthcare outcomes in the US. And our life sciences division in particular is interested with AI and ML. That said, before I get to the next slide, the example I'm going to give today is actually on the other side of our business, so in the provider org, automating the operational side of things. Quick blurb about me here. I've been doing this about 20 years. Started my AI and ML journey at Nike, specifically in around 2012, working on their Fitbit competitor at the time, embedding neural nets and ML models into little wristbands. Been doing MLOps, platform infrastructure, all manner of platform ever since. I live in Oregon, in the States, and I have a picture of my son up there because nothing wins an audience over quicker than a cute toddler. I think he's cute anyway. He's cheering on the Buffalo Bills there, and they were supposed to play in Dublin this year, but it doesn't look like that's going to happen. Maybe next year. So Stork. We had a problem at Datavant about a year ago. We're doing around 30 million medical record requests annually. So what that is very simply we get in a request to gather and then release medical charts. Again, Rob spoke on this a bit earlier. And then we manually process that. And so what it looks like in practice is, we get these faxes or emails or handwritten requests. We get them in, and then we manually, we read them. There's a bunch of folks on staff that sit there with one window open where they're reading a medical record request. They're entering it into a form on the other side. That then goes through a series of quality checks before we actually do the action of pulling the medical charts from various EMRs, EHRs. Do some more quality checks, and then we actually go about delivering to the requesters for the data there. Just pull up my notes again here. So as you might imagine, that's slow and super error prone. We manage all of this in some in-house software that we've built, and so we wanted a solution using AI and LLMs that could plug directly into that system seamlessly, right? So a few of the other speakers have talked about being able to get buy-in from the org. We had all this inertia. It's kind of hard to turn the tanker and change the process. And so one of the ways that we've had success doing that is by picking a small area to focus on, delivering something that's seamless. It doesn't really cause a lot of abrasion for the org, plugging it in, and then it's as if it was part of the flow all along. And so, oops. Clicker's been a little finicky. But yeah, so here just trying to illustrate that, got the random slide generator again. So yeah, just trying to illustrate that, we want to keep the rest of the process as is. We need to keep a human in the loop. We can't, for various reasons, legal and compliance-wise, remove the human from the loop. But we wanted to automate the upfront process here. And so we wanted to create something that was a simple API call for our legacy system so that it could integrate that way. One consideration here is we can't just call out to ChatGPT. This is medical information, so we have to roll our own LLMs internally. Real quick aside to just go through some of the terms here, so I'm not using our jargon without any context. In terms of these record requests, we want to talk about whether or not something is logged, meaning very simply whether or not we've gotten the relevant data out of it. Required field is exactly what it sounds like. It's required for us to actually consider something logged. And key fields, we track a certain subset of the fields just to denote whether or not we bear any risk on this as PII, so first name, last name, things like that. So we want to track these fields separately to make sure that we have secure and data with high fidelity. Here I just wanted to dig into the actual construction of this, the actual architecture of what we ended up building. So as I said, we needed something that could plug in as an API call to this existing system. We implemented a fast API container system to take a single endpoint request for these documents. That goes through a few steps of data cleaning before eventually passing off to Amazon TextRack to run OCR. So we convert these, what are essentially photographs in most cases, to actual structured text data with metadata attached. We then pass it off to a naive Bayes classifier, so basically just trying to understand what type of request is coming in. We have 5 or 6 kind of top-level classes that we're able to fine-tune our LLMs to, and so knowing up front which type it is really helps us drive accuracy and recall there. And then once all that is done, we do a little more data cleaning, and we pass off to an LLM that we've fine-tuned in Amazon SageMaker, and we also host it there too. So that's a very scalable solution. Just a few notes on the LLM itself. We have experimented with QN and various llamas. The Llama 3 8B model is, for our use case, the most performant, using Hugging Face in AWS SageMaker, as I mentioned. And a key point here, which a few other speakers have alluded to, is we had the data for it. In the end, we don't actually need to use as much as we have, but we have 8 years of historical context to pick from here, right? So we have folks who are doing this day in and day out, and we can train the model to be experts in that way. Wanted to make a note on prompting here. So it can seem like magic, but everybody here has used ChatGPT, and on the back end, that's really what we're doing, right? We're prompting this LLM the same way you would prompt ChatGPT directly in the chat. We say, you're an expert on this. Give us some JSON back. Give us temperature is 0, so we're not getting a lot of randomness, and do this data extraction for us. And we were wildly successful in just under a year rolling this out. 87% of the documents that we see are fully logged, and so that means we can remove a human from that step, at least. We're 96% accurate. We, for various operational reasons, only process about 60% of all of our volume that we see as a company, but we're set up to scale for that. We can do this in under 10 minutes, as opposed to sometimes days, depending on different considerations. And we've saved 15 to 20 million by some estimates, just in terms of labor there to do those things. I won't spend too much time there. Wanted to give some shout out to the team. None of them are here, so they won't see this, but didn't want to steal all the credit. A lot of smart guys working on this. That's all I have.
Thank you very much. Do we have any questions? Yes.
Hi. I assume you implemented some sort of automation for the tracking of accuracy when doing the extraction of data from the unstructured to structured. Can you speak a little bit to that?
Yeah, so because we have to still have a human in the loop on the back end, we report all of our logging metrics out, and then if a human does intervene to change something, so they're verifying what we've done with the LLM, if they intervene to change something within, I think it's 5 days, then we stop taking credit for having done that fully. And then we store those instances off, and then we're able to retrain the model based on our mistakes.
So just spot checking to evaluate accuracy?
Not so much spot checking, because every record has to actually be handled and then fulfilled. If the human in the loop they're checking every single, they have to verify every field for every request. And so it's more than spot checking, it's every single instance.
Okay, perfect, thank you.
Yeah.
Any other question? Yes.
Thanks for a very interesting talk. So one thing you get with someone who's human in the loop is that the AI can be so good, but the human in the loop just goes on to autopilot and starts ticking yes to everything and sort of accepting. Did you find then that basically you got some kind of reduction in the accuracy, compared to human in the loop versus the old human-only system?
Actually, when you have, just functionally, when you have someone sitting in front of a screen entering this data for 8-10 hours in a day, it's very difficult to do with the same fidelity by the 8th hour that you're going to be able to do with your morning coffee. And so we actually saw a marked improvement overall because humans make errors. So we kind of live, I always describe it as kind of living in the habitable zone. We're not too far away from the sun, we're not too close in terms of this being the perfect project. We still get to rely on our human operators, but we still get to kind of make some magic in the meantime.
Thank you.
Any other questions? I have a question. So it was interesting to see that you trained models in-house with 8 years of data. So how was that? How long did it take? Was the data already, which was already on your storage, or did it have to be cleaned up further? So it was interesting.
Yeah, so because we have this in-house software where our operators are actually working on it, we have a Postgres database that backs that. And so it was just in its kind of normal operational form, meaning application developer, Postgres backed. So of course it required some cleaning. Again, the human error does enter into it. But also again, we're kind of in that sweet spot where we had this beautiful data set for the most part. I've seen way messier or absent data, and so it's really a great problem to solve that way because we had it labeled and it's easy to train. We have too much data actually. The funny thing is we have 8 years of data. We really use like a very small subset of it because it's
and that was enough to have good accuracy.
Yeah. I mean, we iterated over time to get to where we're at, but we feel we've kind of reached the functional limit of where the LLM can perform.
Thank you. Thank you.